So today we're starting our circle unit, and we are going to take a look at some vocab, see where it's located on the circle, get some concepts in our head, and start to take a look at some angle measures and how they relate to some of the arcs on the circle. So we can see here it says circles are often denoted by their center. So for instance, I would call this circle A, since the center point is A. That would be the name of the circle. And it says there, in the following diagram, circle A is shown with points B, C, and D on the circle. So we have to list three segments that represent the radii. Radii is plural of radius. So the radius is always going from the center to the edge. So segments that I could have would be, say, AD, it's one radii. I could have AB. We could also have AC. Now we could list this in the opposite order as well. We could call it DA or BA, does not matter, as long as it's going from the center to the edge. Okay. Letter B, give the segment that represents the diameter of the circle. Okay, so the diameter has to go through the center, and it has to go from edge to edge. So our diameter would be DC. And now it says, what's the relationship between the length of the diameter and the length of the radius? So we could say that the diameter is equal to 2 radii put together. Or we could look at it in the other direction. We could say 1 radii is equal to half the diameter. Okay, and then a chord. A chord is probably something new. A chord is a segment that has both endpoints on the circle. So for instance, I could say DB is a chord. It has both endpoints on the on the edge of the circle. For that matter, using that same definition, D to C is also a chord. Even though it's a diameter, it's a special chord because it is your diameter, but it still takes that idea of chord where it has both endpoints on the circle. Okay. And then for letter D, it's saying, all right, so I see a triangle. I see triangle DAB, and it says, why must this be isosceles? Okay, so in order to be isosceles, we need to have two congruent sides. So looking at this picture, I can see AD and AB are both radii. So because they're both radii in a circle, I know all radii are congruent. So that gives me two sides of a triangle that are congruent. So if I know that those two radii are congruent, I now have a triangle with two congruent sides. And a triangle with two congruent sides is isosceles. So anytime you have a triangle formed by two radii on a circle, it will always be an isosceles triangle. Okay? Number 2, taking a look at something called major and minor arcs. So we have a diagram, we have circle O, meaning O is the center of the circle. We have A, B, C, and D, they're all on the circle. And DB is a diameter because it contains the center. We have to name major and minor arcs. Okay, so a minor arc is going to be an arc that is less than 180. And a major arc is now going to be an arc that is greater than 180. So then you might say, well, what is it if it's 180? It's a semicircle. Okay, so we're going to name the minor arc, thinking something less than 180 that has A and B as its endpoints. So when you name a minor arc, you're going to go in the direction of the circle that you name it. So I could name this AB, and because I'm only touching those 2 points, that would give me my minor arc AB that's less than 180. And you'd have an arc symbol that's just a curved symbol on top of those 2 letters. Now, in order to make it the major arc, okay, major arc, I'm going to probably need 3 letters to show the direction. I could call this arc A to D to B, that's one option. I could call this arc A, C, B. Notice either option whether it's ADB or ACB, have A and B as the endpoints. Okay, try it again. This time we're going to name the minor arc that has A and C as the endpoints. Okay, so I want less than 180, so can't go in this direction. I'd have to go in this direction. And I could call that arc ADC. I could also just call it arc AC. That is okay. So either ADC, that's a little bit more precise, telling you the direction, or you could name it arc AC. Minor arcs are the only arcs that can be named with 2 letters. Major arcs must have 3 letters to help show us the direction that we're traveling. So if I'm going to name the major arc, I'd have to go A to B to C in order to get an arc that's going to be greater than 180. Okay, so that's major, minor arcs. Next thing we're going to take a look at is something called a central angle. A central angle is just going to be an angle where the vertex is at the center of the circle. So we know what a central angle is, an angle whose vertex is at the center of the circle. Since I know that, we can then determine the size of the arc that it opens up to. So if I were to look at this picture to the right, I can tell you angle ADB is a central angle because the vertex of the angle D is located at the center of the circle. Okay. I also know that angle ADB is opening up to this minor arc AB. You know, it's minor because I can see it's less than half the circle. So we know the measure of the arc then will be equal to the measure of the central angle that it intersects. So by looking at this, if I know that this angle is 112, I can see arc AB is what it opens up to. I can tell you that that arc has to also be 112. So the measure of arc AB is 112. So then they want to know, well, what's the measure of arc ACB? So notice the 3 letters, that's the direction we're going to trace it out. So I go from A around to C, around to B. You have to hit the points in that order. So that's making up the rest of the circle if I go in this direction, A to C to B. Well, if I have 112 from the minor arc, I know there's 360 degrees in a total circle. If I subtract that out, it's going to leave me with what's left over, which is 248 degrees. Okay, on the back, let's try some more. So in the circle at the right, BC is our diameter, and we're going to try and find some more angle measures. Now, keep in mind, we talked about the triangles that are formed are isosceles. So for instance, this triangle DBA, it's an isosceles triangle. And I know it's isosceles because these are both radii. And since it's isosceles, I know not only are the 2 sides equal, but my 2 base angles are equal. So since I'm looking for angle DBA, that means this angle up on top, I know that it has to be equal to this angle over here because those are the base angles of the isosceles triangle. It has to be 18. Okay, if I try the other one, I have to find angle BEA. So BEA is this angle. Again, I can see triangle BEA is isosceles. And if this angle is 26, then the other base angle also has to be 26. And we're going to find angle DAB. So DAB, first off, that's a central angle because it's located at the center. It's part of that first isosceles triangle that we looked at. And knowing that a triangle has 180 degrees, and I already know 2 of the angles, I could subtract those out and find that that's 144 degrees. So our central angle is 144 degrees, which also means this arc, a minor arc from B to D, is also 144 degrees. Central angle is the same as its arc. Okay, going to our second triangle, triangle BAE. So triangle BAE, I have to find this angle BAE. Again, it's a central angle. Again, I know there's 180 degrees in a triangle, and I have 2 out of the 3 angles. So by removing that, that's going to leave me with 128 degrees, which is also a central angle, which will also give you the measure of this minor arc being 128 degrees. And lastly, we have to find angle DAE. Well, DAE is not really part of a triangle. I could make it a part of a triangle, but I can also look and say, well, it's part of a circle. So I know that was 144 and that was 128, and if I put it together with the angle that I'm looking for right now, it should form a full 360. So if I take 360 and I remove our first angle, remove the second angle, what I'm going to find is that angle DAE, that leftover angle of 88 degrees. So that's also a central angle, which also means I can find its arc measurement that it opens up to, which is also 88. And again, if I take all the minor arcs and add them up, that should still give me 360. Okay. And lastly, we're going to take a look, do a little bit of a proof. It says, so in the diagram of circle M, M being the center of the circle, AC is the diameter, we want to show that angle BAC, so in this picture that's like saying we want to show the measure of angle 1 is equal to half of this arc. Okay, well keep in mind, maybe just something to write down. I know to begin with angle 3 is equal to the measure of arc BC, so keep that in mind. Okay, so why is triangle BMA isosceles? Well, again, BMA is isosceles because I have two radii that are congruent. I know that BM has to be congruent to AM since they're both radii of the circle. That makes it isosceles, and since this triangle is isosceles, then we know base angles are equal in an isosceles triangle. So that tells us angle 1 and angle 2 have to be equal. Okay, so why should we know then angle BAC is equal to 1/2 of BC? Well, we could do this a couple of ways. Keep in mind what we said. We know that that measure of angle 3 is equal to the measure of arc BC. Our central angle is equal to the arc. Okay. Going back to early information, early in the beginning of the year, angle 3 being an exterior angle of that triangle is equal to angles 1 plus angle 2. But remember what we said, we knew 1 and 2 were equal. So if I did a substitution, I could tell you, well, 3 has to equal, let's say 1 plus 1. Could also equal 2 plus 2, but we're trying to find 1 plus 1. Because 1 is the measure of angle BAC. So if I keep working with this, I could combine that, and I could say, well, 3 then is equal to twice that measure of angle 1. Okay, well, if I divide by 2 to figure out, well, how big is angle 1? So I'm going to divide that by 2. This is showing me, well, measure of angle 1 is only equal to half the measure of angle 3. Okay, well, let's go back to what we knew from here. Measure of angle 3 is equal to that arc BC. So I could do a little substitution. Replace angle 3 with that arc BC, and look at what we just found. Angle 1 is equal to half of arc BC. Angle 1 is called an inscribed angle. And so I can tell you the inscribed angle, notice where the vertex is located on the edge of the circle. An inscribed angle is equal to half of that arc. So we've learned two things here today. A central angle equals the arc. The inscribed angle will equal half of the arc. Okay. So if we try this last question, it says, in diagram below we have arc ABC. So now notice I have to trace it the way it's labeled, A to B to C. And they're telling us that this is 268 degrees, which hopefully that makes sense. That's a major arc that's greater than 180. So we have to find the number of degrees in angle ABC, which is this angle here. They're saying, how big is that? Well, we know we have 360 degrees in a circle. And right now we know 268 of it. So left over, I have 92 degrees. So that 92 degrees is for this remaining arc. And if I take a look at angle ABC, noticing where that vertex is, the vertex is on the circle. So angle ABC is inscribed. So we just set up above, the measure of our inscribed angle has to equal 1/2 the arc it opens up to, which is 92. So I take half of 92, and I can tell you it's going to be, it's going to be 46 degrees. And so what we've just found is the measure of angle ABC. So those are some basics, some vocab, some basic angle measures. We're going to be doing some more of this in class, and hope this helps. Have a great day.